We are going to continue from our previous class. In our previous class, we talked about what you call heat and explained to you what heat is all about. So before I start our today's class, which has to do with heat capacity, let me just recap or refresh your memory on what you call heat. Now, as I told you before, heat is a form of energy and it has to do with what you call temperature difference. So if you want to get the heat of a body, or if you want to get heat of a body, there must be temperature difference, which means a cold body and a hot body, or that difference in temperature that you are going to have for a body. When a body is cold and when a body is hot, that difference in temperature will give you what you call heat. So in today, we are going to focus more on what you call heat capacity. So let's start with what you call heat capacity. Now, this word heat capacity, if you do not call it heat capacity, you can also call it thermal capacity. I hope you understand what I'm saying. So, if you do not call it heat capacity, you can also call it thermal capacity. Now, what is this heat capacity or this thermal capacity? Before I explain what heat capacity is all about, I need to give you the formula of heat or quantity of heat. So whenever you hear the word heat or quantity of heat, we normally represent that using what you call H. So this H simply means what you call quantity of heat. It simply means what you call quantity of what? Of heat. And quantity of heat is always measured in what you call joules. So the SI unit of quantity of heat is joules. Now this quantity of heat is equals what you call Cp theta, whereas this Cp is called heat capacity. This Cp, I can call it heat capacity. I call it heat capacity, or I can also call it thermal capacity. So if I do not call it heat capacity, I can also call it thermal capacity. So heat capacity or thermal capacity. You might be wondering what is the unit for this one. Well, after my explanation, I'm going to give you the SI unit of heat capacity or thermal capacity, because if I say it now, you may not know how I came about it. So I want, when I'm done with my definition and making it the subject of the formula, you see how I came across the unit of heat capacity. Now, the next one is what we call the theta. That theta is called what? Your temperature. So that one is called your temperature. So this one is your temperature. And the SI unit for measuring temperature is what? Kelvin. And would normally represent Kelvin with letter K. Remember, joules is always represented with letter J. So let me go back to what I wanted to explain today, which is what you call heat capacity. Now, from this formula now, I have given out that H is equals to Cp theta. This is one of the formula for heat. There are other formulas for heat too, but when we start going deeper, I will give you other formulas for heat. So if you make Cp the subject formula, I have it as Cp is equals H over what? Theta. Like it divide both side by theta, so I'm going to have it as H over theta. And what do I mean by H now? Now remember I told you that H simply means your quantity of heat, or you can call it your heat. So quantity of heat is your H. And the other one is called your what? Temperature. And your temperature, and this temperature we are talking about now, it just temperature by 1 Kelvin. So if I may ask you now, from what I have here now, the quantity of heat, the unit for quantity of heat is joules, and the unit of temperature is Kelvin. So the SI unit of heat capacity is what? Joule per Kelvin. It's also joule per Kelvin. So that's the SI unit. So before we proceed now, let us define what heat capacity is all about. heat capacity. Remember, if I do not call it heat capacity, I can call it thermal capacity. Before I start my definition, what do I have here now? What did I call this H now? I call this my H as what? Quantity of heat. I called it quantity of what? Of heat. Quantity of heat equals, what did I call this one? This CP is called thermal capacity or heat capacity. Thermal capacity. Thermal capacity or heat capacity times. Then this one is what you call what now? Rise in temperature or temperature change. Rise in temperature. Rise in temperature or temperature change. So that your teacher has to do with what you call temperature. Now remember that this topic that we're talking about, thermal, heat, and this one has to do with rise in temperature. There is a topic that we'll be talking about that doesn't involve rise in temperature. That is what you call the latent. So, but this is not what I'm about to explain right now. So let's proceed with what we have for the moment. So what we have now is that I can just I can now define, because I was about to define what heat capacity is all about. So definition of what you call thermal capacity. The definition of thermal capacity. Thermal capacity. Let's define thermal capacity, or you call it heat capacity. Now, what is your heat capacity? As I said last time, heat capacity or thermal capacity is the quantity of heat. Remember, heat capacity is equal to is the what? Quantity of heat. So I'll just say quantity of heat. Quantity of heat required is the quantity of heat required. Quantity of heat required to raise to raise the temperature the temperature the temperature of a body by what? By 1 Kelvin. So that's it. Quantity of heat required to raise the temperature of a body by how many Kelvin now? By 1 Kelvin. That is exactly what you call heat capacity. And remember what I told you, that the formula for heat capacity still remains what? Your Cp is equals your H over what? Over T. So this is what you really need to take note. Now, since you are aware of this now, let's move over to it now. Now, since you are aware that we have it that our Cp, which is our heat capacity, equals to H over what? Theta. And you know, when I made the subject of the formula, the heat, quantity of heat, when I made quantity of heat the subject, I have it as Cp over T. I'm just repeating what I've written over and over again so that you understand the formula. Now, this heat capacity alone, heat capacity alone, Cp, which is your heat capacity alone, is equals mc. It's equals what you call mc. That is mass times specific heat capacity. So your heat capacity, heat capacity, which is known as your Cp, is equals mass of the body, or mass of the substance times specific heat capacity of the substance. Specific heat capacity. So that's the formula. So remember that this mass, your m, from what I've written here original, your mass is your m, and your heat capacity, your specific heat capacity, is your small c. So from what I have here, from what I have here now, I can now say that my heat is equals, my quantity of heat is now equals, I will remove this heat capacity and I'm not going to place mc. That is, I'm going to say mc, and then this theta is going to equal, remember I call this theta rise in temperature or temperature change. So I can also call it temperature change this way. So that is what we have now. So it simply means that whenever you apply heat to a body, that quantity of heat that you apply to a body that causes the temperature of that body to rise is called heat capacity. Remember, let me repeat that again. That quantity of heat you supply to a body so as to increase the temperature or to raise the temperature of that body, it's called what? Heat capacity. So whenever you hear the word heat capacity, whenever you should take note of one thing. In terms of heat capacity, there must be what now? Rise in what? Temperature. There must be what you call rise in temperature, or there must be what you call temperature change, because it's only when we have rise in temperature that's when we have your temperature change, or what you call temperature what change. Yes, you can also have, that is what you call temperature change. So in terms of that, that is why this formula I wrote here, you can also, in a proper way, you're supposed to write the formula as Cp equals H all over change in theta. Heat capacity. Heat is the quantity of heat applied to what? To raise the temperature of a body. And the temperature of a body, there must be what? Rise in temperature of a body. So, but I didn't want to bother you with this formula. I just wanted to keep it so that we'll just mention it last. So since you're aware of this formula, whereby we have it at, remember that we started from here, we got it at quantity of heat is equal to your heat capacity times a temperature or rise in temperature, whereby I say that this heat capacity is the same thing as mass times specific capacity. And when I say this now I did substitution. So I brought down this my heat capacity. Sorry, yes, my quantity of heat. Remember. Then I now say that this is my heat capacity, and I replace this my heat capacity with what? Mass times specific capacity. Mass times specific heat capacity. Then the other one is your temperature or rise in temperature. So that's why I'm using delta theta. Delta theta just simply means what you call change in temperature. And I once say that in this scenario, whenever we're talking about this scenario, there must be what? Rise in temperature, or there must be what? Temperature change. So that's one thing that you need to take note of. Okay, so since you are now aware of this now, if I make C the subject by dividing everything by m theta, let's forget about this change for now. Let's divide it everything by what? M theta. So what do we have here now? I cancel my m and I cancel my theta, or cancel my change in theta, or let's say change in theta. It doesn't really matter for now. So what do I have now? And let me remove that change for now, because let's be working with the term temperature alone. Even though that the temperature must change, it's only when we start using the formula I will now put the change. But for now, since I'm explaining, let me remove this change for now. So I'll just say your small c is equals h over what? M theta. And what does this mean now? What does this h equals to m theta? What does it mean now? Now remember, I call this your h as what? Quantity of heat. Remember, this your h is called your quantity of heat. You should remember, always remember that, please. Quantity of heat, quantity of heat. And as I am writing down this, please, I would like you to take note of all these things. So bring out your jotter and be writing them out so that you will not forget anything that I'm saying here. Now, whereby this m is called your mass, and this your theta is called your temperature. Temperature. So if I ask you now to define this your small c, and this your small c is called specific capacity. This your small c is called specific heat capacity. Specific heat capacity. If I ask you to define what specific capacity it's all about, you don't really need to cram it, or you don't need to, so in fact you don't really need to memorize it. So for you to define it, you just say specific capacity small c is the quantity of heat, specific capacity of a body. It must be of a body. So specific capacity of a body is the what? Quantity of heat required to rate what? To raise a unit mass of the body by what? By 1 Kelvin. So that's what we have it as your specific capacity. That is exactly what we have as what you call what specific capacity. So I'm going to go back. I'm going to say that again. I'm going to say that again. So let me write it down. Let me write it down here. Let me write it down. So let me write it down so that you get what exactly what I'm saying. So let me write it down. So I just said that specific capacity. Okay, let's use this space. I just said that specific heat capacity definition. Specific heat capacity. Specific heat capacity, which is your small c, of a substance. It must be of a substance or of a body. Okay, let me not use the word body because the substance can be a solid. The substance can be also a liquid. So what? So let's use a proper word like of a substance. So I think a substance is more better. Specific. So substance can be anything. So let me not use the word body. So rather let me use substance. Okay. So specific capacity of a substance is the quantity of heat required to raise the temperature temperature to raise the temperature of a unit mass to quantity of heat required to raise the temperature of a unit mass of the substance by 1 degree Celsius or 1 Kelvin. So it's either you use 1 degree Celsius or you use what you call 1 Kelvin. So that is what we have here now. Now for you to determine, the next thing we're going to talk about is how do we actually determine the specific capacity of any substance. Now remember, I said that the substance can be a solid. It could be solid, it could also be liquid. But before I talk about whether solid or liquid, let's talk about how do we determine the specific capacity of a substance. Now before then, you should remember that I once told you that your what did I say, that your specific capacity is equals h over what m theta. So there are two ways to determine what you call the specific capacity of a body. Determine the specific heat capacity of a body, of a substance. Yes, of a substance. Actually supposed to be of a substance. Always remember, I always forget that. Everything that comes into my mind is body, 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 body. Body, one that's supposed to be a body, and the one that doesn't supposed not to be a body. Okay, so quick one. Sorry for that. Now, I just said that how they determine the specific capacity of a substance. So, and I said that the substance could be what? It could be what you call solid. It could also be what? Liquid. Substance can be any of these. Now, there are two methods. One, we have what you call the electrical method. We have what you call the electrical method. So we have two methods that we use to determine. And number two, we have what we call the mixture method. Method. So basically, I think I'm going to focus more on the electrical method for now. Then maybe talk about mixture method if need be. But for now, I'm going to specify. I'm going to measure the formula for mixture method. So I'm going to focus some of my calculations on the electrical method. So this is what we have here now. So if you want to determine the specific capacity of a substance, we have two methods. We have the electrical method and we have what you call the mixture method. And before then, you should recall one thing. I told you that this heat of a thing always occur between two systems or two body. One body is going to be cold, one body is going to be hot. So which means that one body will be losing heat, another body will be gaining heat. So let's recall one thing. What did I say you should recall now? Remember, I once told you that we have heat loss. Heat loss must be equal to what you call what? Heat gain. So one body will be supplying heat, the other one will be gaining the heat. Now let's take an example. Assuming you have your pot of soup that is very cold, you place it on your stove. Your stove will be supplying heat to that pot of soup, which is the stove is losing heat to the pot of stew or pot of soup. Then your pot of stew or your pot of soup is gaining the heat. So, and how do I know that it's gaining the heat? It's gaining it because it's gaining it by becoming what? Hot subsequently. So with time it becomes hot. That is how I know that this body or the pot of stew is gaining heat. So that's what you hear. But remember that the opposite happens in your refrigerator. Remember, who did I say is going to lose your heat here? Your stove, your electric stove, your gas cooker is going to be losing heat or supplying heat to this thing. But I think this example or this analogy that I use is not proper. Let me use the proper way, the proper one that I have. Assuming you have a hot body, your hot body will always lose heat to your cold body. So which means that heat flows from where now? As I told you before, it flows from higher temperature to what? To lower temperature. All right. Now, since I've already talked about it now, I've say something about this now. Heat loss. Now, let's remember the formula for heat. What are the various formula for heat? Let's talk about the formulas for heat. Since I've already said it's going to be heat loss equal to heat gain. What is the formula for heat? Formulas of what? Of heat. Let's talk about the formulas of heat. Now, one of the formulas of heat that I once told you from the beginning of this class is H is equals mc theta. This is called quantity of heat, mass, specific capacity, and temperature rise. Then if we are going by the electrical method, you should bear it in mind that, or even though we're not being, talking about the electrical method now, remember I'm giving you the formulas of heat. You can just say that heat is equals to PT. PT. What is P now? That P is equals your power. That P is known as your power. And the SI unit of power is what? Watts. Watt is always ended up with W. So when you have something like 2W, it is called 2 watts. Then your T is known as your time. And your time, the unit of time is what? Seconds. It must be in seconds. So if it is not in seconds, you do your conversion. Now, since I have it at your quantity of heat and your H still remains your what? Your heat or your quantity of heat. Your quantity of what? Of heat still remains your quantity of heat. And the unit for quantity of heat still remains joules. Now, the next thing we're going to do is, you remember one thing. You recall that one thing. What will you recall now? That your power is equals your IV. Your power is equals IV. So since I have power to equals IV, this is one of the formulas that I'm using. That is one. So since I remember that power is equals to IV, I can now derive or obtain that quantity of heat is equals IVT. IVT. IV is taking the place of power because I remember that power is equals to IV. So this is another formula for it now, whereby I is known as your what? Your I is known as your current, your electric current. So this one is called electric current, and the SI unit for electric current is ampere, represented as A. V is called your voltage, and the SI unit for voltage is what? Your volt, and T still remains your what? Your time. Sorry, let me write this very properly. So this is your V. So your T still remains your time, and your H still remains your quantity of heat, which is also in what? In joules. Now, since you are aware of all this that I said now, what next am I going to have? I still need to give you other formulas for heat, because I needed to know all the formulas for heat, so that by the time you are solving any question related to heat, you will know the formula you're going to apply. So I've given out the first formula, I've given out the second formula, I also have this. This is one of the formulas. Okay, so let me call this one 1. Okay, I'm just deriving. So this is one of the formulas. So I have this as one of the formula for heat. I have this. I have this as one of the formulas for heat. Then I also have this as one of the formulas of heat. So these are the three, but I can still continue to derive other formulas. So what will I recall this time around? I'll recall, according to Simon Ohm's law, that V is equals IR. V is equals IR. And since V is equals IR, I can now have it. So I'm going to remove this my V here and replace it with what? IR. So which means that I'm going to obtain that my H is equals, I'm going to say V is now IR. So IR times I times I will give me I squared RT. So this is one of the formulas that I'm having now. So remember, I squared, because I times I. Remember, I removed this V. I removed this V and placed IR. So which means what I did was that I just say that H is equals I bracket IV. Sorry, is it IV? No, IR. Okay, IR T, because this is your V. I times I, it will give me I squared. Then RT, I will now say RT. There's one other formula that is also still remaining. So since I've gotten this now, from your Ohm's law, you can also make I the subject. So if you make I the subject, you are going to have it as I equals V over what? Over R. So from this formula I've written now, I am going to obtain another one. And what next am I going to obtain? I am going to obtain that H is now equals, then this place I have my I will replace it with V over R. And V over R, V times V will give me what? It's going to give me V squared R and what? T. So this is another formula. 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 Then the last formula that I want to give you is what you have, that H is equals to ML. Remember that this V I have here is called your voltage. Then this is your R. Okay, I didn't mention R. This your R is known as your resistance. Your R is known as your resistance. And the SI unit of resistance is what? Ohms. You will be seeing this omega sign. So whenever you see a number that ended with omega sign, it represents the units of what? Resistance. So from this now, I've written the last formula, which is H is equals to ML. And ML is known as your what? M is known as your mass. Do we have mass here? So your M still remains your mass. M is your mass. And your L still remains your what? Your latent heat. Latent heat. I am not going to mention anything about latent heat right now. Maybe in my next class, I'm going to mention something about latent heat. So, but for now, we are concentrating our attention on what? The quantity of heat we are supplied to a body to do, to increase. It must increase the temperature of that body. It must. So what we are teaching now is how we supply heat to a body. Sorry, how we supply heat to a substance to increase the temperature of that substance. So for now, I'm teaching anything that can cause temperature increase on a substance. That's what I'm teaching now. So in our next class, my next class, I'll be talking about the quantity of heat that you supply. It will not increase the temperature, rather it will change the state. So these are the two things you are expected to know in heat, everything about heat. So for now, let's continue with this temperature rise. All right, so before I go over to solving questions or fixing some other things that you need to know, before I explain further about this electrical method and whatever, let me give you a recap of all the formulas of heat. So the recap of all the formulas of heat, what do we have here now? Let's recap again. So go along with me. What is the formula for heat? We just say that one of the formulas of heat is H is equals what? MC theta. This is one of the formula. Then we also say that H is equals to what? PT, whereby P is called your power and T is your time. Then we can also went further to say that your P, we have it as what? IV theta. because IV is your power, to have it IV theta. Then we also went further to say that it's going to be what I squared RT, because your V is equal to IR. Then we also proceeded and said that it's going to be what V squared over RT. Then finally, we just say that H is equals ML. So these are the various formulas of heat that we use in solving anything about heat capacity or specific capacity. But there's one key thing that I told you that you must know if you want to solve questions related to what you call heat capacity or heat capacity or whatever. Remember that this quantity of heat can also be called energy supplied. Remember, I call this H. I call it, you can call it heat. You can also call it quantity. You can call it, sorry, you can call it what? Heat energy. Heat energy. You can also call it quantity of heat supplied. You can call it quantity of heat supplied. You can also call it energy supply, because heat is energy. You can also call it energy what? Supplied. So all these places you see where they are writing H can be called heat energy, quantity of heat supplied, or energy supplied. So these are the ways, these are the terms, or yes, these are the terms it always come in form of. So before I proceed in whatever we have, you should remember one thing. The key thing that you need to remember in solving it related to heat is what you call heat loss. Heat loss equals heat what? Heat gain. Now, I told you that there are two methods of determining specific heat capacities. So if you want to determine your specific heat capacity, determining specific what? Heat capacity. There are two methods that we use to determine the specific heat capacity of a body. And the two methods are, one, we have what we call the electrical method. I told you we have what we call the electrical method. We have electrical method. And two, we have what we call mixture method. So let me explain each of these methods. Let me start with what we call the electrical method. Now for the electrical method, for you to have this now, what do you have in terms of this electrical method now? Electrical method is done like this, assuming, and I told you that this substance can be liquid, it can be solid. So assuming you have what you call your calorimeter. Yes, sorry, this is your calorimeter. Your calorimeter is always lagged. Sorry, forgive my hand, it's supposed to be straight. These are supposed to be straight, you know. I don't know why my hand is just wavering this period. So they always lagged, like inside this place, it contains what you call a cotton wool to avoid heat loss. So you have your solid like this, perforated. Let's say you will make this opening. These two openings are serving for two things. You know, you can oil it. You can oil it so that it will help out. So the next thing I'm going to do is this first opening that I have here. I'm going to place my thermometer. Let me just say, you know, if I want to measure my heat, I'm going to use my thermometer. So this first hole now, I'm going to place my thermometer there. I'm going to place my thermometer. Then this second hole now, I'm going to place my heater in the second hole. I'm going to place my heater in the second hole. And since I'm placing my heater in my second hole now, this is my heater. I'm going to connect it to an electric supply or electric source. So I'm going to connect it to my electric source, to electricity. This is where I'm going to connect this one. Now, if I switch on my electricity, you know, electricity will always give one thing. Heat supply from this heater. Heat supply from this heater must have the formula as H is equals to IVT, or I, which is your current, V, which is your voltage, and T, which is your temperature, or H equals to I squared RT, or H equals V squared over RT. Then the question now is, all these formula that I'm writing now, which of them and when do we use each of them? When do we use each of them? It depends on the question they give to you. Assuming they just mentioned to you that your heater, for your heater that is supplying the heat, they gave you the current of the heater, they gave you the voltage of the heater, and they told you how long the heater was turned on or was switched on. You use the first formula. Then at the same time, assuming they gave you the current of the heater, current that passed through the heater, they give you the resistance of the heater, and it gave you the time. You use this second one. So this is for IRT, but this is for IVT. Then if you are giving the voltage, no current, resistance, and time, you use the last one. Remember that the work of this thermometer is to measure what you call the change in temperature, whether the temperature that is going to rise, like, for us to know when the temperature is going to rise. Now, from the look of this now, since we're going for electrical method, which is the first one, this experiment has to explain the first parameter, which is our electrical method. So since we're going with the electrical method, this your heater, remember this container, I called it a calorimeter. And this calorimeter is lagged. It is lagged like lagged. This calorimeter is what? Lagged. It lagged with cool or anything to avoid heat loss. Then this space, now this space that you see here, or this thing that you see here, is your solid. This is your solid. Now what happened now? Remember, now this your heater will now, if I turn on, or if I switch on my heater, my heater will become hot. And whenever it becomes hot now, remember that this my solid is cold. This my solid is cold. So this my heater will become hot, and since it has higher temperature, it will now supply the heat to this solid. So which means that the heater will lose heat, and the solid will do what? Will gain heat. So remember the formula as I told you before. Heat loss by who is going to lose the heat this time around now? By the heater. Is equals heat gained by the what? Heat gained by the what? By the solid substance. This method also work for liquid as well. We have that of the liquid. So since I have it that heat loss by heater is equals heat gained by solid now, what is the formula for heat for heater? And I gave you the formula for heat for heater as IVT, I squared RT, V squared RT. So any of these could be the formula, but basically we normally use this first one to do the explanation. But in some exams, you'll see where these ones will appear. So for heat loss by heater, I can just say IVT. Remember, H, which is your heat, is IVT. H, which is IVT, is equals, since we are talking about solid, the solid must have mass, the solid must have specific capacity. Remember, I told you that this method, this one, can also work in liquid as well. It can also work in liquid as well. Liquid can be water. It can also work in liquid as well. So, but from what I'm explaining now, I am using only solid to do the explanation for now, but it's still the same thing. So since we have solid, or since we have liquid, the solid or liquid that we have, depending on the scenario, must have mass. It must have specific capacity, and there must be temperature change. So for that reason, this side that is written as heat gained by solid, the formula for heat that we're going to use here is going to be mc theta. So I'm going to say mc theta. Remember, IVT is a formula of heat for what? Electricity, for electric heater. Mc theta is the formula for heat for substances, whether solid or liquid. That is for your substances. So from this now, I can break it down and say that IVT is equals mc change in your what? Temperature. So I can also proceed to say IVT is equals mc change in temperature is going to be what? Your final temperature, which is called theta 2, minus your initial temperature, which is called what? Theta 1. So I can use this depending on where I'm going to see it to solve any question that I want to solve. So let's look further. Let's see if we can get some question to solve. Let's see if I can solve a question under that before we proceed to other ones. Let's look at this question now. Let's take a look at this question. Now this question says, in an experiment, remember I've explained to you the experiment that we normally use to determine the specific capacity of a substance. It can be electrical method, it can also be mixture method, but currently we are talking about electrical method. We are yet to mention mixture method. So let's proceed. In an experiment, listen carefully, to determine the specific capacity of a metal. What are we determining here? We are determining what? The specific capacity, and specific capacity is represented as what? Small c. Now they say that the specific capacity of what? Mass, 2 kilogram. They gave you the mass. They gave you the mass of the substance as what? 2 kilogram. Mass of the metal as 2 kilogram. An electric heater was placed in a hole, as I showed you before, in the metal, and a thermometer was placed in another hole in the metal. The voltage across the heater, so the voltage across the heater was 8 volt. They were even lucky to mention, they told you that this 8 volt is called voltage. So coming to this, I'll just say that my V is equals 8 volts, 8 volts, and current 6 amp. So they even mention current. I'll just say I is equals what? 6 amp, 6 ampere or 6 amp. Okay. Now they said if the heater was switched for how long now? 5 minutes. So my time that was in this event is equals 5 minutes. And this 5 minutes, I can convert it to second by saying times 60. So I can just say times 60 to get what I want. So, 5, this is going to be in seconds, like 5 minutes. This is minutes. This 60 seconds. Like if you say 5 times 60, assuming you have something like 5 hours and you want to convert it to seconds, you just say 5 times 60 times 60. But if it is for 5 minutes, if you want to convert it, all you say, just say 5 times 60 alone. So that's it. So let's leave this one aside. So let's neglect this one. So I'm going to put my seconds here because it's going to be in seconds. Okay. And they gave me what did they say now? 5 minutes. And the temperature of the metal rose by 8 degrees Celsius. So what is my temperature, which is my theta? My theta is equals 8 degrees Celsius. 8 degrees Celsius. So that's it. Now the first question says that we should calculate the energy supplied to the body. We should calculate the energy supplied to the body. That's the first question. And the second question says you should calculate the specific heat capacity of the metal. You should be careful with this question because this question is going to be like your exam question. So I need you to watch closely how I'm going to solve this question. So watch closely and listen carefully on how I'm going to solve this question. Now let me start from the first question. The first question says I should calculate what? My first question says I should calculate energy supplied to the body. And I once told you that this energy supply can also be written as what? As H. Now, who supplied energy to this body? The only person that supplied energy to this body is what? Your electric heater. Remember, I told you heat loss is equals to heat gain. Your electric heater will supply heat, and your solid, that solid that we have here, the metal that we have here, will now gain the heat. So from this now, just say H is equals, what formula am I going to use? Should I use IVT, or should I use I squared RT, or should I use V squared over RT, or should I use MC theta? So which of them am I going to use as the formula for heat supply? Because energy supplies has 3 formulas, which are IVT, that is H is equals, I've given that in your previous class, in the previous ones, like few slides now. I gave you that as H is equals I squared RT. I also gave you that as H is equals V squared over R and T. So from this now, I'm going to pick the first one. And why am I using the first one? The reason is because I was giving current, I was giving voltage, and I was also giving time. So I'm going to use that to solve the equation. So I'll just basically say, what is my current? What is my current? My current, according to this question, is 6 ampere. How I know is because it ended with a ampere. Remember that ampere. Even they even did good by even naming it, calling it is current. But assuming this word current is not there, you identify the current by the unit, which is 6 ampere. So I'll just say 6 times, what is my voltage? My voltage is 8 volts, the one that ends in volts, 8 volts. I'll just say times 8 times, and what is my time, which is the last formula? My time is equals to 5 times 60. I'll just say 5 times 60. So what is going to be my answer? Now let's calculate and see what's going to be my final answer. Now let me bring up my calculator. Sorry, calculator. Okay. All right, this is my calculator coming up. So I'll just say 6 times 8 times 5 times 60 equals, the answer is going to be what? 14,400. So I'm going to have the final answer as what? 14,400 joules. But if you want to leave your answer in kilojoules, depending, but the answer is supposed to be in joules. Assuming we divide by 1000, it's going to be what now? Divide by 1000, I'm going to have it 1, 2, 3. I'm going to have it as 14.4 kilojoules. But always, you can always leave your answer in joules. Please don't stress yourself going to that of kilojoules. I'm only showing you so that you know about kilojoules. Now the second question says, the B part of the question says, the specific capacity of the metal. It's going to be heat supply or heat loss. Heat loss supplied, heat loss or heat supply equals heat what? Gain. It's going to be equal to heat gained. And heat loss or heat supplies, we got it as 14,400. 14,400, you know, that is your, this one, 14,400 equals, heat gain is going to be MC theta. MC theta, because whenever you want to talk about heat gain, the formula for heat gain of any substance, whenever a substance is gaining heat, the formula is always one formula, which is what? MC theta. But for heat loss, it depends. It's either, if it is by electrical method, it's going to be IVT or I square RT or V squared over R times T. That is if it is by electrical method. But if it is by mixture method, it's still going to be MC theta. Just take note of all this that I'm saying now. Take note of that, please. So quick one. I will just say 14,400. 14,400 is equals, my mass still remains my 2 kg. You know, it's always good to be my 2 kilogram, times my C, which is my specific capacity, times my temperature is what? My 8. That is, temperature is 8. So what next am I going to do? I'll just divide both sides by 2 times 8. I'll divide both sides by 2 times 8. 2 times, this is times. Cancel 2, cancel 2. Cancel 8, cancel 8. So what do I have here now? What do I have? I'll just simply say that my C is equals, C is remaining here. C is equals 14,400. I think I don't have space again. So let me just see if I can go to fix it here, please. You know, so I'll just say 14,400 divided 14,400 divided by what? 16. That is my C. So my C is going to be what? 14,400 divided by 16. That is 2 times 8 is 16. So let's just bring up our calculator again and check what the answer is going to be like. My calculator. Okay, my calculator is already up here. So let me see. So let me clear this one. So I'll say 14,400 divided by 16. So I have it as, the answer is what? 900. So the answer is going to be 900. So from here I'll just say 900 joules, J, like, let me take the next page so that you'll see what I'm writing. So you know, the answer we've gotten is what? Is our C is going to be what? 900 joule per kilogram per Kelvin. You know, you can write the answer as C is equals 900 joule bar dot kilogram minus 1, because this per is something as minus 1 dot Kelvin minus 1. You know, this over is something as minus 1. So this is what you are going to have as your answer for this question. So we have gotten the answer to this this question now. Okay, so let's see if there is any other question that we can also solve using this now. So let's pick another question. Let's solve one more question. So I think after explaining this question, we can just round off this one. And the next time we're going to meet, we're talking about I'll mention something about the mixture method before going over to what you call the latent heat. So let's say we have this question. This question says, okay, I was looking at, okay, so let's look at the next question. The next question says, a 2 kilogram block of aluminium. So I need you to do one thing for me. Anytime okay, let's read the question first before we mention out the parameters. So a 2 kilogram block of aluminium is heated from 20 degrees Celsius to 70 degrees Celsius. The specific capacity of aluminium is 900 joule per kilogram per Kelvin. How much heat is required? Let's go back to that question again. A 2 kilogram block, so our mass is how many? 2 kilogram, and of aluminium is heated from 20 degrees Celsius, which is our first theta. Theta 1 is equals 20 degrees Celsius, and to 70 degrees Celsius, our theta 2 is equals 70 degrees Celsius. The specific capacity of aluminium, so which is our small c, is equals 900 joule per kilogram per Kelvin. Now the question says the heat, how much heat is required. So how much heat is required, that is the quantity of heat. You just say H is equals to this. Remember, what formula are we going to use to solve this question? The formula still remains that H is equals mc theta. So we have it as mc theta. We will now say H is equals, what is your m? 2 times, what is your c? Your c is what? 900 times temperature. Supposed to change in temperature, like I'm supposed to say here as change in temperature, which is something as mc bracket theta 2 minus theta 1. So I'll just say I've given out my m, I've given out my c. What is my theta 2? My theta 2 is what? 70 minus my theta 1 is what? 20 degrees Celsius. So I'll just say H is equals to 2 times 900 times 70 minus 20 is going to give me 50. So I'm going to have it as this now. 2 times 900 times 50. So let's bring up our calculator as usual. So we have it as 2 times 900 times 50. So the answer is what? 90,000 joules. So I'll just say 90,000 joules. That's the heat that I have here now. 90,000 joules as my final answer. All right. I think we're going to continue. We're going to continue in our next class. The mixture method. I'll comment on the mixture method. Then we'll now talk about the latent heat of fusions and vaporization. Then we'll now talk about the scales and the difference that we have, the different thermometric materials that we have in our next class. So just do me a favor, don't forget to subscribe if you are new to this channel, and also click on the notification bell as well to know when I post the next video. So without much, I'm going to see you in my next video or in my next class. Thank you. Peace.